Alright, so we'll just do a couple more examples here for exponential growth functions. So one of the examples is the value of an antique plate after X years. Okay, again, noticing that X is usually always time, right? X years can be modeled by this piece. So really quickly, when you're looking at this, how do you know that this is an exponential function? Okay, the easiest and most effective way is to look right there at the equation, and you see that the x is the exponent, thus making it an exponential function, right? So it says which one of these three graphs here can be used to approximate the number of years, okay, it will take for the plate value to be $30. Now, that sounds a little bit weird. All these graphs look a little weird. So the first thing that we have to do is we have to make sure that we understand what this equation is even talking about. So let's just go ahead and just write this out. All right. Now, although they didn't really go into too much detail, we can actually figure out everything just from the equation and this sentence right here, right? So the first thing is, what does x represent? So x represents the number of years. Okay, great. What does the 18 represent? Now think back to what the equation was. The equation, or the general equation, was f of x, right, or y, is equal to a times b to the x. So these are exactly the same thing. All right, look at the placement. So we have 18. Okay, that's a bad color, 18. And then we have this b to the x. So this 18 represents the initial amount, but what are we taking the initial amount of? Right? It doesn't tell you here, but it does give a clue as to what this problem is about. It's about an antique plate. So we can say that this is the original cost of the antique plate. Antique plate, right? Then what would the 1.05 represent? Okay, so remember that everything starts off here. So we have less than 1, we have 1, and greater than 1. Okay, now we've only really talked about a couple of things. The 1 is where everything starts at. Okay, everything starts at 1. From there, we can either go less than 1. So if the number inside of this parentheses is less than 1, let's say 0.75, okay, this would be a decay, or that means it's decreasing. Okay, if it's just exactly 1, there's going to be no change, which we haven't really spoken too much about, but we focus mostly here. If the number inside of these parentheses is greater than 1, this is going to be a growth. All right, so the amount that you grow by is the difference between this number and 1. So if we have 1.05, okay, and the difference between 1.05 and 1 is 0.05, okay? Now, how do you convert 0.05 to a percent? Well, if you're going from percent to decimal, you move back 2 spaces. If you're going from a decimal to a percent, that's backwards, we're going to go up 2 spaces, making this 5%. So we can say that there is 5% increase, okay, in the plate's value. Okay, so when you look at this right now, we're looking at, oh, it costs $18 in the beginning. Every year, this is the x, right? Every year it's increasing by 5%. So then f of x then would be what? If you know the original cost right now, and every year goes up by 5%, what does the whole thing tell you? It tells you the total value, okay, after x years. Because x is the number of years, so we don't know how many number of years, but after a certain number of years, right? So this is what the problem is about. Now we need to figure out how to graph this. All right, now is this graphed correctly? Well, let's see now. Which one of these would it be? Well, we do know a couple of things. We know that this is the initial amount, okay? So on a graph, this should be occurring. This right here is our, when x is equal to 0, y is equal to 18. So we're literally going to check to see which one has a coordinate when x is 0, y is 18. So here's 0, y is 18. That looks pretty good. Okay, x is 0, y is 18. That actually looks pretty good too. It's because this is a very bigger units, so this kind of looks pretty right. When x is 0, y is definitely not 18. So this is totally wrong. Okay, so we're gonna actually just completely forget about this guy and just look at these two. All right. So the second thing is now we want to figure out when y. I shouldn't even say that because I totally just gave you the answer there. We want to figure out what's the cost when it's $30. Now remember that f of x is the same thing as y. So we want to figure out when this is 30. But you can graph that. You can just graph y equals 30. And this would be the line. It's a horizontal line. Okay, this represents $30. And this represents this equation that tells us how much it is after every single year. Okay, so this is actually x equals 30. We don't want that. We want the total value is 30. So then this would be your answer. All right. This was a little bit more on the technical side. All right, so let's just do a couple examples. It says a table representing the function f of x. Let me write this much bigger. F of x equals 2 times 3 over 2 to the x is shown below. So this is the table for this. Which is true of the given function? Okay, is it true that the function increases at a constant additive rate? Okay, well, what type of functions increase at an additive rate? Those are only linear functions that we've talked about so far. Okay, the function increases at a constant multiplicative rate. So that means it increases through multiplication every time. These are exponential functions. Okay, also, how do you know if it's even increasing? Well, you could look at the graph and see that at the table and see that it is increasing, or you can also look here, right? What is 3 divided by 2? Let me do this different color. 3 divided by 2 is 1.5. And so this actually becomes f of x. Another way to write this is 2 times 1.5 to the x. And remember that if anything here, if this number is greater than 1, which it is, because 1.5 is definitely greater than 1, this would be a growth, so it'll be increasing. Okay, that's another like technical way of thinking about it. All right, so this is for sure going to happen. The function has an initial value of 0. Okay, the initial value, that's our a value, occurs when x equals 0, y equals something. So they're saying that the initial value is 0. Is that true? Okay, well, let's go to where x is 0. Here's x is equal to 0, y is 2. So this is not true, okay, because the initial value is 2, because it occurs when x is equal to 0. So this is definitely not true. Nope. As each x value increases by 1, the y values increase by 1. So taking a look at that, as x goes from 0 to 1, that's definitely an increase of 1. Did this increase by 1? Yes, it did here. To go from 1 to 2, okay, we increased by 1. To go from 3 to 4.5, that's an increase of 1.5. Okay, so that means that this is also not true, making this the only answer. This B right there.